So the situation, to recap, is the following. Demand during peak hours and off-peak hours is a function of both peak pricing and off-peak pricing. The problem that FP&L is trying to solve is to figure out how much generation capacity they need to have available. If they were just trying to meet demand during peak hours, that would be one value. But if they're trying to see what the overall demand is for both peak and non-peak hours, then they come up with a slightly different solution. Here are the data that we have for demand pricing. Here is the cost of capacity. And what we want to do is we want to choose prices so that we can have the capacity we need given the demand that is available. All right, so what we're going to get to here is the following. We need to decide what prices to charge and what capacity to have in order to maximize profit for Florida Power and Light. What we know is that we can only provide as much, we can only satisfy as much demand as we have capacity. And that capacity is going to be determined as a decision variable. Okay? What's our objective function? Our objective function is profit. How do we determine profit? Okay, revenue minus cost of capacity. So the revenue is going to equal to some product of demand times the prices, right? The capacity, cost of capacity, is going to be equal to the capacity we choose times the cost of capacity. Therefore, our profit is going to equal to our revenue minus our cost of capacity. How do we calculate demand? Using the formula that we were given, right? So for peak load, demand is going to be equal to this constant plus the peak price times the peak price plus the off-peak price times off-peak. Right? Let me trace precedence. Okay? How do we get the off-peak demand? Well, the off-peak demand is the same thing. It's off-peak plus, in this case, peak price times that plus off-peak price times that. Okay. So you see how the demand numbers are calculated, right? Let me pause at this moment and just think about this model, kind of in just general terms. If we had gone back and we had drawn an influence diagram that said we wanted to maximize profit, then clearly we would have known that we needed to calculate revenue and we would have needed to calculate cost. Revenue is a function of what? Demand and price. Cost is a function of what? Capacity. All right. So our revenue model basically is saying there's demand times price. Our cost model is saying there's our capacity times our cost of capacity. So that's no different than just simple economics that you're already familiar with, right? The only thing we have to really do is figure out the relationship of demand to prices. And that was given to us. We don't even have to figure that out. The other examples we had to plot the equations and do the calculation for the trend lines and all that. In this case, we don't even have to do that. We're already given the relationship between demand and price. So at the end of the day, it's just simply a matter of picking the right decision variables. So let's go ahead and do that. Let's get into Solver. Our objective function is profit, which we do want to maximize. We're going to do that by selecting the right prices for peak and off-peak and the right capacity. That's what we're interested in. What is the right price for peak and off-peak electricity, and what's the right capacity? Now, after that, all we have to worry about are our constraints. We have one constraint that says what? Our demand cannot exceed whatever our capacities are. What other constraints do we have? Well, it'd be nice to say we have some kind of pricing constraint. We don't want the price to be lower than a certain value. But in this case, it's not clear to me what that value would be, because I don't know what the cost of, well, I do know what the cost of generating the capacity is, but I don't know how to relate that to price. So the only real constraint that I can go with is the demand constraint and the non-negativity constraint. Now, should I also go with the multi-start option? Well, I can. I think I can. The problem that I've got is, you know, I can certainly put bounds on capacity. That's not an issue, right? But can I put bounds on price? I'm not sure that I can, because I don't know what range of prices I should be looking at. Clearly, I want a price greater than zero, so I can put a lower bound on it. If I put an upper bound on it, what would that upper bound be? Well, it'd be a very large number. All right. So let's try to solve it without using multi-start and see what we get. All right. So I'm going to just go ahead and click on Solve. Solver found a solution, and the solution actually doesn't look too bad, does it? Peak load price of $70 per kilowatt hour, off-peak price of $26.50 per kilowatt hour, and a total capacity of 27.5. Note that I use all of my capacity when I'm at peak, but I don't use all my capacity when I'm off-peak.
But that's what you want.
That's a good question. Is that what I would expect?
You want the higher price when it's at peak, and that's when you'll make the most money.
Okay, so now we're going back to that same gut intuition that we have that says you always want to have the most of your highest valued product. Well, we know that's not always the case.
We do, but in this case.
But in this case, it probably is. If you can convince yourself of that, then you can convince other people that that's the case.
Well, if I'm using Solver, yes.
If you're using Solver, then you have a, well, but keep in mind, it's a nonlinear solver. So, would I have got a different answer, for example, remember, I started with prices of zeros here, right? These cells were blank when I first started Solver. What if instead of blanks, I had put 100s in here? What would it still end up at 70 and 26? I think the answer is yes. 70 and 26. So I just did a multi-star too. I started at 0, I started at 100, and both cases converged on the same answers.
How do you know that multi-star is turned off when you first use the Solver?
Oh, because every time I go into Solver options with a new problem,
Okay.
the default is turned off. Let's extend this problem a little bit. Let's play with solver table on this problem. Clearly, our demand function is something that we don't want to change. I mean, we could go back and we could change the coefficients if we thought that there was some reason to do so. But for this problem, I'm going to suggest to you that we ought to leave the demand functions where they're at. So the only other parameter that we might be interested in looking at is the cost of capacity. So let's do that. Let's play with the solver model that says we're going to do a one-way solver table, and the variable that we're going to change is the cost of capacity. And let's suppose we allow it to vary from $5 to $15 in increments of $1. So we're going to look at basically 10 different cases here. And what we want to look at is how prices change, how capacity changes, and how profit changes. So look at where you see the dancing lights, I guess. It's sort of like Christmas racing lights, I guess. But we want to see what happens to both the prices we use, the capacity we select, and the profit we get as we vary the cost of capacity. Now, this is a very good illustration of parametric analysis, all right? We're only changing one thing, the cost of capacity, but we're looking at the effect of that change on multiple results, multiple outputs. So I'm going to click on OK. And there's my answer. So you see my peak load pricing. And interestingly enough, my peak load pricing looks like it only goes up by a nickel or 50 cents as the cost of capacity goes up by $1. See that relationship there? That's a constant 50-cent relationship on my peak load price. On my off-peak price, it doesn't change at all. And my capacity, lo and behold, as the cost of capacity goes up, the amount of capacity that I choose goes down by a quarter of 10 megawatts. So that's what, 2.5 megawatts. So what can I draw from this? Clearly, as my price goes up,
it's starting to decrease.
Yeah. Well, I've got that relationship certainly, but what's of interest to me is two things. Number one is that my off-peak price never changes. Off-peak price is relatively insensitive to the cost of capacity. Let me put that in terms that you may have heard more recently. You see some of these pricing plans that the energy companies come out with, and they talk about free nights and weekends. Does this give you some ideas as to why that might be the case? Right? I mean, basically all they have to do is factor in that price, that off-peak price in your base kilowatt hours price, and you can use as much as you want. It's not going to change. What about the peak pricing? Well, there, clearly, the higher the cost of capacity, the more you have to charge on peak hours to pay for it. But why would that be? Why would you only charge additional to the peak hours for the capacity?
Because to increase the price on the peak, your demand doesn't go down that much. But if you change the price on the off peak, the demand will go down a lot.
Well, the real answer, I think, goes back to the fact that your price, your peak load price, establishes the capacity that you need, right? If you're trying to maximize profit, you maximize profit when you sell exactly as much peak load electricity as you have capacity to generate that peak load electricity. So when you look at the solver table solution, that's just bearing that out. If I increase the cost of capacity, then that means it has to be borne preferentially by the peak load demand. Because the off-peak demand never uses up all the capacity, does it? So as the cost of capacity goes up, the cost of peak load pricing has to go up as well. Because that's what's establishing the total capacity. You need to have enough capacity to meet the peak load demand.
but as your price is going up, your capacity is dropping. I see that $10 for 7031 at 27.5 for capacity, correct?
Yes,
And the
as
price goes up slightly and the capacity is down.
the capacity is going down because higher price is dampening peak load demand. Okay? So that's why capacity is going down. But my point is that the peak load price bears all of the cost relationship to the capacity. All right.
And to optimize that, it would be $10 because you'd be using the capacity at its for what you were generating.
Well, I mean, you got to be careful now, okay? But yeah, the lower the cost of capacity, the more profit you make, right? You have to have more capacity also. So this is what I'm saying when I say there's a real complex interaction. I'm trying to tease out some useful bits of information from this parametric analysis. And the most useful bit of information that I can come up with is that capacity is dictated by peak load demand, number one. Therefore, the cost of capacity figures in directly to the cost of peak load pricing. Off-peak demand does not use up all the available capacity. Therefore, it makes sense that in this case, it wouldn't change depending on the cost of capacity. As long as you always have more capacity than you need, it doesn't matter. And that's a useful insight, I think. Here is the actual profit curve based on the cost of capacity. And you can see that it is a constant slope, right? A constant negative slope. How are we doing? Doing okay?